So we discussed about two types of materials. One is generally orthotropic, and specially orthotropic. What is the difference between these two? What is the difference between these two materials? Yes? What is a generally orthotropic? Morning first hour, why can't you interact? I want some interaction, without which I'm not continuing. I want someone to talk.
Generally, orthotropic means whose material coordinates and Cartesian coordinates are same.
Okay, so the angle is the same. Okay, so this is the loading, and this is the direction of fiber. Okay, so it's in along the direction of fiber, or it can be perpendicular to the direction of fiber. If it is inclined, if the direction of fiber is inclined, then it is generally orthotropic material. Okay, so these two are specially orthotropic, and this is generally orthotropic. So what is the property? How do you say it is specially orthotropic? What kind of properties it will have with respect to the with respect to this shear stress and shear strain, extensional stress, all those? Any idea? Yes. I want some discussion to be continuously happening. Otherwise, you will be keep on writing assignments. I am giving you an option to either interact or give it in writing. What do you prefer? Looks like you prefer written assignments only. Okay, fine. We'll do that. So generally orthotropic means any inclined angle it can have. Okay, the fibers can be inclined and stress is not in that direction. The load applied is not in this direction, it's in other direction. So that is generally orthotropic. And when we write the, what is this matrix? This is called as a, what is this matrix?
Square matrix.
Compliance matrix.
This one. This one. What matrix is this? See, we discussed about stress strain relations, right? Stress divided by strain is equal to the elastic modulus. Okay, so what is strain is equal to?
Stress divided by elastic modulus.
1 divided by E into elastic. Is it correct?
Yes, sir.
So what is stress is equal to? Okay, so what is this one? What is this one? This becomes the stiffness. Correct?
Yes, sir. The other one is compliance.
This is compliance.
Compliance.
Okay, this is compliance. This is compliance, this is stiffness. Okay. Now, what is this one then?
Compliance.
Just now I wrote this.
Stiffness, sir, stiffness.
Sigma is equal to epsilon into E. Okay. You have sigma here. You have epsilon here. This should be E, right? Okay.
Yes, sir. Stiffness.
Yeah. What stiffness? It is reduced stiffness
Yes.
matrix.
Stiffness matrix.
Reduce stiffness matrix.
Okay. It is called as reduced stiffness matrix. When you write it for 2D lamina, it is reduced stiffness matrix. If you are writing for 3D material, it is stiffness matrix. Why Q letter here? Because it is reduced stiffness matrix. If it's a 3D, three-dimensional one, it will be C. Okay. Now, what is the difference between generally orthotropic and specially orthotropic in terms of this matrix? In terms of the stiffness matrix? This term, this one, and this one will be equal to 0 if it's a specially orthotropic material. Okay. Another way of saying what a specially orthotropic material is, if you are applying an extensional stress, you will get only extensional strain. Okay. Why is this 0? If this was non-zero, what will happen? Had this Q16 is non-zero, what would have happened?
It would be generally orthotropic.
Yeah, this term will be there then. Okay, you get this one. Okay, so what happens is, for extensional stress, you are getting shear strain if this term is non-zero. Okay, so that is why there's a 0 for specially orthotropic, meaning when you apply a extensional stress, you get only extensional strain. You don't get any shear strain in a specially orthotropic lamina. If it's a generally orthotropic lamina, if you apply a extensional stress, you will get a extensional strain as well as shear strain.
Yes, sir.
Okay. What happens if you apply a shear stress to specially orthotropic material? What happens if you apply only shear stress to the specially orthotropic lamina? I said extensional stress will give you only extensional strain in a specially orthotropic lamina. What happens when you apply only shear stress? Yes? Chinmay? Chinmay? Hello? Just a second. Okay, we'll continue this. Fine, only half of the class saw that question. Fine, okay. So, what it means is here, you apply a shear stress to a specially orthotropic material. If you apply a shear stress to a specially orthotropic material, you will get only shear strain. Okay, you will get only shear strain because these two terms are zero, which gets multiplied with this. Okay, so Q61 and Q62 is zero, so you'll have only this term. So this shear stress G and the shear strain only will be there. All other terms are zero. Okay, Q16, Q26, Q61 and Q62 are zero. But if it's a generally orthotropic material, what will happen is these terms will be non-zero, meaning if you are applying only the shear stress, you will also have shear strain in the material, okay, as well as extensional strain. Okay, you can have extensional strain for shear strain.
That
Extension,
is in that particular axis, no, sir.
yeah, yeah. If see, shear is applied to the parallel, okay, but you are having extensional strains as well, okay, extending in some direction, that is one direction and the second direction also it extends, okay, longitudinal and transverse, there will be some extension. So you are not applying extensional stress, you are applying only shear stress, but you are getting both shear strain as well as extensional strain. This is the case where when it is a generally orthotropic material. Okay, so
Okay, sir. Understood.
fine. Now what we'll do is we have the formulas for the compliance matrix. We had derived it. So this is the, what is this matrix? It is compliance matrix. The moment you see 1 by E, it is compliance.
Compliant.
Okay, the moment you see 1 by E, call it as compliance matrix. Okay, so nu yx is the minor Poisson's ratio, nu xy is the major Poisson's ratio. So major Poisson's ratio and minor Poisson's ratio is related by this equation. Okay, it is related with this equation. Suppose a numerical is given, for example, E1 is equal to 181 GPa, E2 is equal to 10.3 GPa, mu 12 is 0.28, G12 is 7.17 GPa. Find compliance matrix. Find the compliance matrix. How will you do this? What all information you need?
So we have to find mu21, sir. So using the relation between the major and minor modulus, we find that.
Okay, mu12 by E1 is equal to mu21 by E2.
E2.
What is E1 and E2? What is E1? What is E2?
Young modulus values, young modulus values.
Elastic modulus values of what?
Of material coordinates.
Of the lamina in the longitudinal direction and the
Transverse.
direction. Okay, so find this out. This is 0.28 divided by 181 is equal to mu to 1 divided by 10.3. How much is mu to 1? Can somebody give me the answer? Can someone calculate this and tell me how much is that?
0.0159.
0.0159. Okay. So what is this called? What is this called?
The
Minor Poisson's ratio. This is minor Poisson's ratio. This is
Major Poisson's ratio.
major
Poisson's ratio. What does this mean? What does this mean? We are applying load in the longitudinal direction, but the strain can be seen in the other direction. Okay. The load is applied in the transverse direction, but the strain can be seen in the longitudinal direction. That is the meaning of this. Okay. So this is the major Poisson's ratio. This is the minor Poisson's ratio. Now, how do you find compliance matrix? What is the formula? What is the formula? S is equal to what? S is equal to S11, S12, S16, S21, S22, S26, S61, S62, S66. What are these terms? Why 6 here? Why it is 6 here? Why not 3? Why is the 6 here? Why not S13? Yes. If you look at this three-dimensional matrix, okay, this gamma 1 2 is in the bottom, okay, so it's in the last row. It is in the 6th row. That's why these things epsilon 3, epsilon gamma 2 3 and gamma 3 1 are zeros for a 2D lamina. So only this one, and this one will be there. So we write it as S61 and not S31. Okay. So you follow this order. You follow this order and then do it. That is why in this matrix it is S61, S62 and S66. Okay. Understood?
Yes, sir.
Okay. Now, what is S11 equal to? 1 divided by E1. What is S12 equal to? What is S12 equal to? Minus mu
minus mu by
by
E1.
E2. Okay, minus mu 1 by E2. S16 is 0. What is S21? Minus mu12 by E1. What is S22? What is S22 equal to? 1 divided by E2. S26 is 0. S61 is 0. S62 is 0. S66 is what? 1 divided by G12. Okay. Can you calculate all these terms? Can you find what is S11? All these terms calculate. Okay. Some are zeros, some are to be calculated. Okay, calculate this. The values are given here and the formula is over here. Okay, E1 is note down 181 GPA, E2 is 10.3 GPA, Nu12 is 0.28, G12 is 7.17 GPA, Nu21 is 0.0159. So calculate this matrix. Calculate this matrix. So some of the students had said we'll use pen and paper more than MATLAB. The reason was we are required to solve by pen and paper. Is that the only reason that you don't want to use MATLAB much? Or is there any other reason? Yes? Is there any other reason? Nobody wants to answer. I think first standard kids are better. They have been taught how to mute, unmute, everything. They do. They interact with the teacher. Look at how school kids are attending online classes. Learn from them. We have to learn a lot from them, especially the first standard students. So this is I'll take a new script. Okay. So I'll do it in this. Once, if you want to open a new script, go to new and say script. Okay. I've used the clear all command, close all command, and CLC. Clear all, what does it do? It clears the workspace. Okay. Close all will close all the other windows. The figure, if you have plotted, it will close all those. CLC will clear the command window. And this is the numerical given. E1 is equal to 181 GPA, E2 is 10.3 GPA, Nu21 is 0.01593, G12 is 7.17 GPA. Why there is a semicolon here?
Denote the ending of each sentence, of each line.
If you run this code, okay, in the command window you don't see anything. Okay, in the command window you don't see anything. Suppose I remove this semicolon and run this, you see E1 is equal to 181, it shows. Okay, so if you put a semicolon, it doesn't show, the value doesn't show in the command window. Okay, if you don't put a semicolon, then it will show in the command window. Okay, if I run this, all four values must be shown here now. Okay, you see here, all four values are shown. Okay, so to avoid this, you just need the answer to be shown in that window. Okay, you don't want the given data to be shown there. So what do? You define the compliance matrix. S is equal to, open the square bracket. Okay, it is S11, S12, S16, and then a semicolon to go to the next row. Okay, and then S21, S22, S26, and then S61. This is in the third row. S62, S66. Okay, this is the matrix. Now, what is S11 equal to? 1 divided by
E1.
E1. Okay. You don't want that value to be shown there, so you put a semicolon at the end. Okay. What is S12 equal to?
U21 by E2.
Yeah.
So
Yeah, tell me.
so while declaring the matrix, we put a semicolon between. Will it show the values or not of that, sir?
If you put a semicolon in between, no, this is the matrix syntax. Okay, this semicolon is different and this is different. The meaning is different. Okay, so here in a matrix, if you are defining, it means this should come in the second row. Okay, and this should come in the third row. Okay.
Okay, sir.
S12 is equal to what? What is S12 equal to? Minus,
NU21 by E2, sir.
yeah, Nu21 by E2. I can write it as nu12 by E1, but I have defined nu21 here, not defined nu12. Okay, so I'm taking nu21 by E2. Okay, S16 is 0, and then what else? S21, right?
1.
S21 is equal to, can I put it as S21 is equal to S12?
Yes, sir.
Then S22 is equal to 1 divided by
1 by E2.
E2. And then S26 is 0. Okay. And then S61 is what? 0. S62 is 0 again. S66 is 1 divided by G12. Okay. These are all case sensitive, so make sure you put the same small letters or capital letters, whatever you use. It must be consistent. So if you run this code, you get this. Okay, you get this matrix. This is what matrix is this? What matrix is this?
Compliance.
Compliance matrix. Okay. So what is the units of this? What is the units of this? If
Meter square by Newton.
E1 is equal to 181 GPa. Okay. E2 is equal to 10.3 GPa. G12 is equal to 7.17 GPa. Now what will be the units of this matrix here? What will be the units? Look at this. What
Meter
is
square by Newton, sir.
Meter square per
1 divided by
Meter square
E1? E1 is, yeah, E1 is 181 GPa. So can I write it as GPa inverse as the units of this matrix?
Yes, sir. We can write.
Yes,
You
sir.
can write. Okay. So everything is in terms of GPa here. So when we calculate the compliance matrix, I can write the units as GPa inverse. MATLAB will not give you the units. You have to write the units. How do you find the stiffness matrix from this? How do you find stiffness matrix from
The inverse of this, sir.
Okay. If I take inverse of the S matrix there, I get the what do I get?
Stiffness matrix.
Stiffness matrix. Okay. So this is the stiffness matrix. See how simple it was to just give the command inverse of S. Okay, so inverse of S will give you, what is this? What is this one? What is this one?
Elastic model.
Elastic modulus of 1 something.
No,
E1.
it's not E1. It's not E1. It is Q11. Okay, it is Q11. This is Q12, Q16, Q21, Q22, Q26, Q61, Q62, and Q66. Okay, so this is the stiffness matrix. The previous one was the compliance matrix. Okay, have both over here. Take the inverse of the other, you'll get the other one. Okay, so it's that simple.